So we have two complex numbers here. The complex number z is equal to 2 plus 3i, and the complex number w is equal to negative 5 minus I. What I want to do in this video is to first plot these two complex numbers on the complex plane, and then think about what the distance is between these two numbers on the plane, and what complex number is exactly halfway between these two numbers. Or another way of thinking about it, what complex number is the midpoint between these two numbers? So I encourage you to pause this video and think about it on your own before I work through it. So let's first try to plot these on the complex plane. So let me draw, right over here, let me draw our imaginary axis. So our imaginary axis, and over here, let me draw our real axis. Real axis right over there. And let's see, we're going to go as high as positive 2 in the real axis and as low as negative 5 along the real axis. So let's go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And along the imaginary axis, we go as high as positive 3 and as low as negative 1. So we could do 1, 2, 3, and we could do 1, 2, 3. And of course, I could keep going up here just to have nice markers there, although we won't use that part of the plane. Now let's plot these 2 points. So the real part of z is 2. And then we have 3 times I. So the imaginary part is 3. So we would go right over here. So this is 2, and this is 3 right over here. 2 plus 3i. So that right over there is z. Now let's plot w. W is negative 5. 1, 2, 3, 4, 5. Negative 5 minus I. So this is negative 1 right over here. So minus I, that is w. So first we can think about the distance between these two complex numbers, the distance on the complex plane. So one way of thinking about it, that's really just the distance of this line right over here. And to figure that out, we can really just think about the Pythagorean theorem. And if you say, hey, what about the distance formula and in 2 dimensions? Well, that's really just an application of the Pythagorean theorem. So let's think about that a little bit. So we could think about how much have we changed along the real axis, which is this distance right over here. This is how much we've changed along the real axis. And if we're going from w to z, we're going from negative 5 along the real axis to 2. What is 2 minus negative 5? Well, it's 7. If we go 5 to get to the 0 along the real axis, and then we go 2 more to get to 2. So the length of this right over here is 7. And what is the length of this side right over here? Well, along the imaginary axis, we're going from negative 1 to 3. So the distance there is 4. So now we can apply the Pythagorean theorem. This is a right triangle. So the distance is going to be equal to the distance. Let's just say that this is x right over here. X squared is going to be equal to 7 squared. This is just the Pythagorean theorem. Plus 4 squared. Plus 4 squared. Or we could say that x is equal to the square root of 49 plus 16. I'll just write it out so I don't skip any steps. 49 plus 16. And what is that going to be equal to? That is 65. So x, that's right, yeah, 59 plus another 6 is 65. X is equal to the square root of 65. And let's see, 65, you can't factor this. There's no factors that are perfect squares here. This is just 13 times 5, so we can just leave it like that. X is equal to the square root of 65. So the distance in the complex plane between these two complex numbers, square root of 65, which is, I guess, a little bit over 8. Now, what about the complex number that is exactly halfway between these two? Well, to figure that out, we just have to figure out what number has a real part that is halfway between these two real parts, and what number has an imaginary part that's halfway between these two imaginary parts. So if we had let's say that some complex number, let's just call it a, is the midpoint, its real part is going to be the mean of these two numbers. So it's going to be 2 plus negative 5, 2 plus negative 5 over 2, and its imaginary part is going to be the mean of these two numbers. So plus 3 minus 1, 3 minus 1 minus 1 over 2 times I. And this is equal to, let's see, 2 plus negative 5 is negative 3. So this is negative 3 halves plus, this is 3 minus 1 is negative 2 over 2 is, so let's see, 3 minus, let me make sure I'm doing this right. 3, so I'm taking the mean. 3 minus 1 is 2, divided by 2 is 1. So 3 plus 3, negative 3 halves plus I is the midpoint between those two. And if we plot it, we can verify that that actually makes sense. So real part, negative 3 halves, so that's negative 1 and a half. So it'll be right over there. And then plus I. So it's going to be right over there. And obviously I didn't draw it perfectly to scale, but this makes sense that this right over here would be the midpoint.